everyone. Thank you so much for joining our session today. And we're really excited to introduce Azure SQL Database Edge, a new small footprint edge-optimized data engine with AI built in. My name is Jane, and I'm the lead product marketing manager for Azure SQL Database Edge. And I'm really honored to have two colleagues of mine joining me on stage today. And Greg, would you mind to introduce yourself?
Hi, everyone. I'm Greg Pruitt. I am Chief Architect and Distinguished Engineer for Lenovo's Data Center Group. And I also have the privilege of leading our Innovation Center. So I'll talk to you a little bit today about some of the cool devices we've built in our Innovation Center. Saurabh?
Hey guys, hi. My name is Saurabh Agarwal. I lead the program management team for Azure SQL Database Edge. And I'm excited to talk about some of the cool stuff we are bringing to Azure SQL Database Edge to enable AI streaming and analytics right on the edge. Thank you.
So just to have a quick recap of the agenda for our presentation today, we will evaluate some of the industry trends that is happening in this edge compute, data, and analytics field. And we will get more into how we build out new capabilities for data streaming and management and the bi-directional movement between cloud and the edge. And of course, we want to supply you with some of the demos that to showcase the capabilities that we introduced into the core SQL engine. Of course, the innovation together with our partners is also a crucial part of how we are jointly going into the developer community and enable all of you to build new innovative apps. So here is the landscape. Essentially, we are seeing, as you heard from Satya and Rohan earlier today, the landscape is truly shifting. And there are a lot of things that are driving the change, but essentially some of the key industry experts are calling out that by the year 2025, there will be 75% of enterprise data that are being generated and processed outside of the traditional data center or cloud, and up from less than 20% today. That means a lot. And there are a lot of changes or factors driving this change.
So that statistic, Jane, that you have on the bottom of the chart, that's staggering. I mean, my read of that is we're going to have to design applications differently. We're going to have to do something fundamentally different here. Because if the data isn't in the data center or in the cloud, if the data is actually at the edge, we're going to have to architecturally think about that and putting the compute closer to the source of the data. When we do that, it gives us opportunities to address some of these challenges, right? If we can actually put the compute close to the data, then we can have real-time response without the latency of needing to go back to the central data center or back to the cloud. It helps us address some problems maybe with data governance. Maybe that data is not allowed to move. Maybe it can't move out of the state or out of the country. And so by actually leaving it on the edge, it helps us address some of these data governance issues. And there's a whole lot of cool things happening with hardware devices and purpose-optimized accelerators and FPGAs that may help us at the edge to be able to do better analytics right there near the source of the data.
Right, and what is also attributing to this growth in data processing, or the prediction from Gartner, is the evolution of 5G as a communication technology and the advent of IoT mesh architectures where you have multiple IoT devices talking to each other, facilitating distributed computing. And the other thing which is important to think about is the cost efficiency for operational needs. For example, if you have petabytes of data originating on the edge, moving that data to cloud is, in its raw format, it's going to be inefficient and it's going to be cost ineffective. So what you would rather want to do is process that data locally on the edge and only move aggregated or results from that processing back to cloud for scale deployments or scale analysis. So all of these factors combined are indicators of how the data growth is happening on the edge and how computing needs are changing across edge and compute cloud platforms. Jane will talk about the evolution of how data is growing and what are the challenges we see in terms of data processing on edge.
So the change is quite tremendous if we really measure that in terms of the volume of data. And this is just a small sample of forecasting out the IoT type of data being generated in the next 3 years. Double-digit growth, and both in terms of structured data and non-structured data. However, it's really noteworthy to see that not all those data being generated are put into decision-making today. So less than 50% of structured data, which is typically being used for decision-making, are not quite being used for edge compute. And the percentage of non-structured data is even less. So when we set out to talk to our top IoT enterprise customers and our solution providers, they are telling us, like, of course, there's always the challenge of limited size and compute power, the complexity of managing those data sets, the additional learning curve for the developers for learning new tools and systems, and the security side of things. But the most important thing for this adoption is that there's very few edge-to-cloud data platform choices in the market that enables this true architecture. And no one really wants to create another data silo that resides within the various pockets of their edge environment. And of course, there are physical challenges too.
Yeah, there's not just application challenges. There's challenges with getting this equipment to run in non-traditional spaces. And think about running edge compute and storage in a truck. Let's just say we're talking about a logistics customer. And you may have high heat in the truck. You may have excessive vibration. It may be a dirty environment. So you've got to think about environmental aspects. It may not be secure. Most of our data center equipment runs in a well-secured, dedicated data center, maybe with biometrics to prevent people from physically accessing it. Equipment in the back of the truck may or may not be secure. It depends on whether someone remembered to lock the door. There's limited space to put these devices. So they have to be really smaller form factor, lighter weight, flexible in terms of how they can be mounted. And I think very important to both of us, both application and device, is we really have to think about the management. There's no IT staff on the truck, and there's no IT staff that's going to visit the truck necessarily. So this has to be centrally managed. We have to be able to maintain the hardware, upgrade firmware. We have to be able to maintain the application and the SQL Database Edge itself. So all of that, I think, needs to be factored into these challenges. You also have connectivity issues, so you may not be able to have a wired access connection. You may need to be cellular or 5G access. And so all of these things we really had to think about as we were designing our products, both hardware and application.
So essentially, given those challenges, we think this is the right approach of dealing with how to build out the right intelligent cloud and intelligent edge architecture. Two things are very important for us. Number one is consistency. From application platform to security, identity management, the tooling side, and especially how you design the analytics side of things, everything really needs to be consistent across the edge to the cloud. And the second aspect is comprehensiveness. Together with our partner ecosystem, we really want to have a full spectrum of offerings that are open to our developer community, all the way from the Edge MCUs to the Edge stack. So with 25 years of engineering effort behind us, this is what we are trying to get into this space with the proven engine of SQL Server running on premises and Azure SQL Database running in Azure Cloud. Those two are what you have been familiar with. Enterprise class, mission-critical workloads, that's the industry-leading engine behind it. What we're trying to get into is this edge space where a lot of the interactive devices, edge gateways, and edge servers are really the mainstream. So therefore, we are introducing a small footprint, turnkey, ML-capable data engine to be run both under connected scenario as well as disconnected scenario. And it's not just introducing the core engine into a smaller footprint. We actually have been researching in this space and building some brand new capabilities like data streaming, movement, time series into this core engine so that it's truly optimized for edge. And this is really meant to complement the existing Azure IoT offering from Microsoft and to run that with local data storage across all device tiers. So this is what we are revealing today with prior keynotes with Rohan and other executives. First of all, is the choice of platform. In the edge space, it's not just the x64 devices that are running. So we need to enable the platform to support the ARM type of devices and be able to run on Windows, Linux, and also in a containerized fashion. And the second thing is that in the edge space, a ton of data being generated are time series based. So how do you tackle the workload for time series data streaming and time series data analytics? That is also something that we want to build into the core SQL engine. And of course, if you're familiar with the journey of the core SQL engine, getting all those AI built in, you know that we've introduced Python and R in earlier versions, and we're also introducing Spark to run in the same core engine as of 2019. As Greg mentioned, this has to be turnkey. No one has an army of DBAs getting into the edge and to every single devices. So we need to have a single management plane so that we can deploy and update the applications and the database from that single portal. And last but not the least is the most secure and industry-proving engine that is running behind your data on the edge. And essentially, data security is a crucial part of everything that is happening on the edge, and we are having all the security features of Enterprise Edition and Azure SQL Database in full play, protecting your data on the edge. So, in a nutshell, you have local streaming, storage, and machine learning all in one, running in this container in small footprint. And also, you're getting the single common programming surface area so that you can have your application running either on the edge or in your data center or all the way in cloud. So with that, I'm going to hand this over to Saurabh so that you can see an ARM container running SQL Database Edge in action.
Cool. Thank you. Thanks, Jane. So before we get on with the demo, a quick show of hands as to how many of you guys develop against SQL or a SQL database in cloud? OK, perfect. And how many of you guys are familiar with SP_read error log or the SQL Server error log file? Perfect. So let's do this. Let's switch to my demo machine where, okay, this is it. So where I'm connecting to, or I'm telnetting into a Ubuntu or an ARM chipset, which is running Ubuntu 16.04, right? And before I run the actual SQL error log or the logs for the image, you can see up here that I have had my SQL Edge container running on this device for the last 2 days, right? And just to make sure that you guys know that this is an ARM server, if you do a quick LSCPU, you do see that this is a ARM64 chip, right? So before I start doing querying and all that, let me quickly run the logs on this container and show you the fact that this is running your familiar SQL instance. Yep, right over here. Thank you. So I'm running my SQL instance. In this case, I took the SQL 2019 bits and I ran it on an ARM instance. And this machine is 4 cores, 2 gigs, a chipset from rock64 or pine.org. Right? Now, we talked about the surface area or the programmability area, right? So to demonstrate the programmability area, I'm going to use the IoT Smart Grid sample from SQL Server samples on GitHub, which uses temporal tables, column store, not hackathon, not in memory, because we still don't have in-memory running on ARM. It uses CDC to track the changes which are happening on the tables, and so on and so forth. So let me go ahead and start my workload on this device. So here I am inserting about 200 records every second as, in terms of my smart meter readings for the King County area. And while this data is being inserted into the database, I can use a familiar Power BI dashboard to query the data on this device. Now, most of my queries for the report is using column store, which works on the Edge instance, in cloud, and in SQL Server on premises. Right. So essentially, we are providing you with a common T-SQL programmability surface area for Edge, premises data center, and cloud, along with the capabilities around security, availability, and reliability of SQL Server, and the performance of SQL Server. So that was the first part of the demo.
That's cool.
Thank you. So I'll show you one more demo, which if you were in Rohan's keynote, we talked about the manufacturing floor example. I'll talk about that example again, and then we'll get into a separate scenario, which is a cold chain logistic company scenario where computation is happening on the truck. So what is the reference architecture, or what is the optimized architecture for Edge and cloud, and how does Azure SQL Database Edge fit into that architecture? Right? So in the slide, the bottom half of the slide is where we talk about the Edge, and the top half of the slide is where we talk about cloud. So you have multiple sensors which are streaming in data to a Azure SQL Database Edge instance. Right? This data can go and sit in either the relational store or the time series store for Azure SQL Database Edge. Now, when the data is in the database, or actually, let me take a step back. Before the data is stored in the database, the streaming engine provides capabilities to run simple ML algorithms like classification, anomaly detection, and things like that to analyze the data even before it is written to a table. So if the data, depending on your scenario, while the data is being streamed in, you can take decisions whether that data is meaningful or not. Right? And then once the data is stored in the database, the in-database ML analytics capability of SQL and SQL DB Edge allows you to run ML algorithms. They could be R, Python, Spark ML, even Java, against this data to analyze and get inferences out of this data. One key thing which we are enabling is that you can train your models in cloud using Azure ML or AutoML or your own Python or R scripts. You can bring down that model to edge and do the scoring on the edge. So you train your models in cloud with scale data, and then use that model to infer or do scoring on the edge. And since we are talking about a cloud and edge architecture, we are obviously enabling a scenario where your Azure SQL Database Edge can talk natively to a cloud target. That target could be SQL in cloud, it could be Cosmos, it could be DW, or it could be a SQL database on premises. So we enable both data synchronization from edge to cloud and device or reference data synchronization from cloud to edge. Essentially a bi-directional data synchronization mechanism between edge and cloud. And as I was saying earlier, we enable the capabilities around where you can train your models on edge, in the cloud, bring them to the edge, and then do local scoring and send the results back to cloud for further training of your models, right? And then the last piece I'll talk about is that we natively integrate with Azure IoT. So if you have an Azure IoT deployment, you can just plug in Azure SQL Database Edge, and we will work out of the box. We provide capabilities to directly connect to the IoT agent and the IoT Edge Hub to enable data movement. The last part about the familiarity of the analytics and BI platforms, which enables you to do or build once and deploy anywhere across cloud, on-premises, and on edge. Right, so let's see the second scenario in action. OK, so I'll get this out of the way. And let's, at some point, I will show you a Visual Studio project which talks about a cold chain scenario. OK, so first things first, right? If you were in Rohan's keynote earlier, we talked about how a manufacturing assembly line floor where you have these industrial robots performing one or the other action on the assembly line. It could be a robot which is moving things around. It could be a robot which is fixing things, or something like that, right? And each of these robots, they send telemetry data to a hub or to a gateway for analysis, right? Now, in the absence of a processing engine on the edge, you need to pipe this data or move this data to a central unit, which could be in your data center or in cloud for processing, right? With Azure Data Edge, Database Edge, what we are enabling is local processing on the floor itself. You could even take it further, notch further, and do the local processing right on the robot itself. All you need to do is attach a Pi chip or an ARM chip to the robot, pipe all that data, telemetry data on the robot to that ARM chip, and do the local processing on the robot itself, instead of moving that data across the organization. So let me do this. Let me talk about the data which we are generating and how we process that data. OK. Interesting, right? So this data is being generated at a per second interval, sorry. And there are about 35 different data points or different sensor output which I am generating every second. And this is not just for one robot. This is for a multitude of robots. So you can imagine the amount of data which is getting generated and getting streamed into Azure SQL Database Edge, right? So the streaming engine, let me just pull that up. So the streaming engine of Azure SQL Database Edge, what it is doing is it is reading that data set and doing anomaly detection on that data as it is being streamed in. So think about, in this scenario, I have 35 robots emitting 35 different sensor outputs every second. Imagine the amount of data which is being streamed into this system, and you're doing anomaly detection on that data at that point itself. Right? And that's not it. While we are doing anomaly detection on that data, if we do find an anomaly, which is mostly in this case the rise in engine temperature, and I'll talk about that, we will pipe that output to an anomaly table. Right? If not, we will hold that data and aggregate that data at a, in my scenario, I'm doing a 30-second aggregate, but you can choose to do an aggregate per minute, per 5 minutes, 10 minutes, depending on your scenario, right? So I'm writing anomaly data to my local data store, and I'm also writing my aggregated data to my local data store. That's not it. My streaming engine is also capable of writing simultaneously to an Azure SQL database or an on-premises SQL database without compromising on the data inputs it is receiving from the robots. So without dropping events, I can write simultaneously on the local store and on my remote Azure or data center store. Right? But in this case, I am writing mostly to my local store, and the two things which I am doing as part of my data being written to the tables is that the first thing, I run a query, or I can run a query on my anomaly data to understand what were the anomalies in the last 2 minutes in my data set. So in this case, I had 4 anomalies in my data in the last 2 minutes. And most of these anomalies is in the engine temperature. So in my case, I classify the data as an anomaly if my robot engine temperature is more than 115 degrees Fahrenheit. Right? And if I do not have an anomaly, that data gets written to another SQL table at a 30-second interval. So if you notice, in all of these samples, 30-second aggregated sample, my engine temperature data is less than 115, which is what is my threshold for anomaly. Right? And that's not it. I am taking some key matrices in terms of engine fan speed, outside temperature, humidity, and so on and so forth, and aggregating all of that data into a single table. So to recap, 35 different sensors from 35 different robots, all getting streamed in, all getting aggregated into the same table. So I am not just reading the data while it is being streamed in, I'm also performing joins on that data set while that data is being streamed in. How cool is that, right? And to make it even more better, I wrote a Python script. I wrote a Python algorithm which was trained in Azure ML. And I brought that model. So you basically see the model definition as part of a var binary input which I'm supplying to my tsql predict function. So we'd support not just bringing actual Python and R scripts, which you can bring to Edge. You also have native tsql functionality to do scoring on the edge. To predict, or to actually in this case, I'm trying to find out what is the root cause for my anomaly. And in this case, the anomaly is mostly because there was a fluctuation in the ambient temperature and ambient humidity, which resulted in the robot trying to, or the robot fan trying to cool the engine much more faster. So essentially, an increase in the ambient temperature resulted in an increase in the robot engine temperature. Right? Now, that's about the querying part of it. So to top it, let me pull in a Power BI desktop to ensure that we have the same programmability surface area. In this report, I am calculating what were the anomalies in the last 1 hour from my edge instance. So I had about 118 anomalies. Actually, let me go and refresh this data to make sure that we have the latest data set, right? So my number of anomalies did not change a lot. I still had about 118 odd anomalies in the data. And on the top of the report, you see the steady state scenario where if there is no anomaly, what is my engine temperature? What are my ambient temperature and humidity values, and things like that. So in a scenario where there is no anomaly, I see that my humidity or ambient humidity was about 38, and my ambient temperature was about 73 degrees Fahrenheit. But in a scenario when there is an anomaly, my ambient temperature increases to 84, and the ambient humidity is about 50. Right? So there is an increase in the ambient conditions, resulting in an increase in the temperature and the fan speed of the robot engine. So these are all the other artifacts of the robot when there is an anomaly detected in the data stream. Right? Now, as I was telling you earlier, right, my streaming engine is capable of writing this data set to Azure SQL Database also. Let me show that in action. So in my T-SQL notebook, if you notice, I'm connecting to an Azure SQL Database Edge, sorry, Azure SQL Database instance in cloud, right? And let me run this query and show you the actual data right this moment from the SQL database. So this data is 2300 hours on 6th of May, which is UTC time. So current data being written into the local engine and also being written to the cloud engine. So that's the power of Azure SQL Edge, Database Edge, which we are trying to bring to market. OK, let me revert back to or let me put on my PM hat and talk about the other use case scenarios for Azure SQL Database Edge. Right? So one of the things which we are enabling, and we talked about this, is the distributed computing architecture which IoT mesh and everything is enabling, and the fact that IoT is a hierarchical architecture. So you would notice that you have a lot of leaf devices, like the actual sensors, which are sending data to a gateway server. And then there are multiple gateway servers which are talking to an edge server. And that edge server, in turn, talks to a cloud target or an on-premises target. With Azure SQL Database Edge, what we want to enable is the capability to be able to run this database platform on any of these layers of the hierarchy, except for on actual sensors. Because these sensors are typically very small scale MCU units. So our target is that if your device has enough processing power, and when I say enough, I mean about 500 odd MB and more, and let's say 2 cores of processing power, you should be able to run SQL on top of that. So one of the key things which we are trying to do as part of the innovation is reduce SQL Server footprint. Quick question before I get to that actual number. What is the current footprint for SQL Server on an on-premises environment? Memory footprint. Do you guys have a rough estimate of what we currently run with? For memory? I like that idea. Actually, I like that number. Now think about that, and think about potential 250 MB of footprint for SQL Database Edge. That translates to, going by that 5 terabyte number, that translates to over 2,000, right? If I'm doing my maths right. So 200 or 2,000, whatever, times reduction in the footprint. But the actual number for SQL Server on premises is somewhere close to 2 gigabytes footprint. And we are coming down to somewhere in the range of 250, 300. That's the target. And we want to get there. Right, so talking about as I was saying earlier, right, we are trying to enable a scenario where you have your hierarchy running SQL Edge, and then you have your cloud targets where you can send your aggregated data to Cosmos, SQL DB in cloud, and SQL DW. And then you also have the ability to train your models in Azure ML and bring those models to on-premises or on the edge. Sorry, yeah, this one. This is a utility scenario where we are working with a well-known utility company in the States, where we are trying to gather the data they capture on the edge. So this is essentially a industry which does a lot of mining work, right? And the organization which supplies them mining equipments and also equipments to analyze the outputs or the produce from the mining. Right? So essentially what we are trying to enable there is enable sensors to capture data in terms of the quality of the produce, in terms of the ambient environment, in terms of functioning of the machines and everything. Do ML analytics right on the edge on that data, and then use that ML inference to derive actions right on the edge. So for example, if you are on an oil rig, somewhere in the middle of an ocean, right, where temperature and volume of data being piped through the gas pipeline is of importance, right? And if you detect an anomaly, you can take actions right on the edge to shut down the gas valve, right? Or to reduce the pressure, or whatever it is, right? So we are trying to enable that kind of capability with Azure SQL Database Edge for these utility companies and mining industries. So that also enables the fact that we can do move sensitive data to cloud once it has been processed on the edge. Okay, one last demo, and then I'll hand it over to Greg and Jane to talk about how Lenovo is investing in the edge landscape and how we are partnering with Lenovo to enable those scenarios. So, okay, this demo is built on a logistics company where this logistics company has partnered with a grocery chain. Right? Think about a grocery chain called Contoso.com, right? Where users can log on to their website and order items, whatever the items they want, right? Now, most of the websites today give you a standard shipping price for first day's delivery, next day delivery, and so on and so forth, right? But imagine a scenario where while you are doing your, selecting your items and you are clicking on checkout, your grocery store can talk to the logistics company and the trucks on the field to give you an actual cost for delivering your data or items within a 1 hour or 2 hour window. Right? Wouldn't that be cool? So that's the scenario which we have as part of this demo. So, okay. So I have this truck which is currently en route between points A, B, C, and D, right? Now, as a user, I will go and connect to my coldbone.com website and try and select some items for checkout, right? Let's say I am selecting whatever XYZ items. And I click on checkout. Now, as part of my shipping address, let's say I pick Marimoor Park. You guys are all familiar with Marimoor Park, right? It's right around the corner from our office. And when I click on Get Shipping Methods or Shipment Methods, a call is sent to the central database for the cold-born, the grocery chain. That call is routed to the logistics company, the central database on the logistics company. From there, that call is routed to all the trucks in King County, or currently active trucks in King County. And they report back with calculations done on the truck as to what time and how much cost it will take for a truck to deliver, so actually pick up those items and deliver to the customer. So I can give you a 2-hour window, a 4-hour window, and so let's say I immediately want my items. I have a few folks coming in. They really like tomatoes, so if I go back to my report, now once the user has selected the shipment method, all of these calls get routed to the truck, where the truck driver gets a notification that a route has been added to their existing route, and that they need to pick up and deliver the items at Marimore Park. So excuse the internet, I guess the Bing API is taking a bit of time, but essentially you do see that your A, B, C, D, which were there originally, and now you have Cold Creek also, which is essentially the Marimore Park area, which has been highlighted. Sorry, my bad, sorry. B is the nearest location which was added, which is Marimore Park. My bad, sorry, thank you. So my truck, instead of going from the original route, it's now delivering to B first, and then will carry on with the rest of the route. And obviously, my truck driver gets, because I'm using Bing Maps API, they get the directions and everything else for the delivery, right? So those are the scenarios we're trying to enable with Azure SQL Database Edge. Now, I'll hand over to Greg and Jane to talk about how we are partnering with Lenovo to bring those capabilities on tiny devices to the edge. Let me switch back, and there you go, Jane. Thank you.
Greg.
Oh, sorry. Oops.
Okay. So when Saurabh and Jane and I first talked about SQL Database Edge, we realized that we shared a common vision. In Lenovo, we're actively looking at edge computing and edge storage more from a device standpoint. I'm sure you know that Lenovo makes laptops and tablets. You may or may not know that Lenovo also owns Moto, so we make phones. So we make a whole bunch of ARM64 Qualcomm Snapdragon devices. We also make servers, traditional servers, the big 19-inch wide ones that go in traditional data center racks. So we make a wide range of portfolio today, both consumer devices and enterprise devices. We are transforming our portfolio for exactly the same reasons that Jane talked about, because we see this shift, this gravity of data moving toward the edge. So we have to transform our portfolio, and we talk about that as intelligent edge. So we're building a whole set of new devices, IoT gateways, smart cameras that can run analytics right on the camera. We're building embeddable devices, can be put in signage or put, beside or into a robot, put into a windmill. And we're also building these servers. So I wanted to talk to you a little bit more about the server, because that's the most recent project that's come out of our Innovation Center. So the product that we just recently announced, I have here with me. If you've recently done a two-person lift of one of our traditional servers, they're quite heavy. This one is not. This one is about the weight of a large laptop. And it's quite an innovative form factor and weight. And the reason that matters in the edge is you don't have dedicated IT space to put this. I'm trying to put this somewhere in the cab of a truck, or maybe I'm trying to put it in a gas station. I don't know if you've been in, small gas stations, but there's no IT racks. It's more like a broom closet. And there's no dedicated power feed, one of those big fire hose drops that brings in 16 kilowatts of power. No, it's a outlet. It's just, plain old 15 amp outlet, right? So the same infrastructure that we build for data center doesn't really work in the gas station, doesn't really work on a truck. We had to design differently. So we thought and really went back and did a clean sheet design to think about what matters for edge. And I thought this might be useful for you to think about as well as you're thinking about your applications and how you architect, because you really need, to build edge computing, you really need to think about the devices you'll need to connect to the protocols of the sensors, how to gather the data, and then how to process the data. And the really cool thing about SQL Database Edge is it's a single platform that lets you create these data flows. And it's a single data model, a single programming model that will work across our devices. So it's a very powerful concept to use in creating these types of edge applications. So from an environmental standpoint, I mentioned before, you've got extended temperature, so we designed this to go 0 to 50 C. Neither one of those is normal, by the way. You might find data center equipment that goes maybe to 35 to 40 C. 55 is really a unique part qualification, so we had to review every part in the bill of materials. But interestingly, 0 is even more challenging. It turns out a lot of electronics don't work well at freezing. So there actually has to be some capability to warm them before they start generating their own heat. Who knew? Yeah. So security. So I mentioned before, the back of the truck or the broom closet in the gas station is not a highly secure area for sensitive data center equipment. Kind of depends on whether or not the last guy remembered to shut the door. And so we designed a unique tamper detect system in this. The way I describe it is that all of the data in here on drives is on self-encrypting drives. But the keys are stored in a dedicated piece of hardware that has an accelerometer. So if I move this, the keys fall out on the floor, logically. So I can disable the data in the device and re-enable it remotely through remote management to ensure that no data is lost if this device gets stolen. We talked about the size and the compactness. The management is key, right? So a server has to have remote management. It's very expensive to do a truck roll, to do a service call out to a remote gas station. There's no, I guarantee you, in most of these gas stations, there's no IT personnel in the gas station. And so you don't even want them opening the recover and trying to replace a drive. If we can service remotely through a firmware update or be able to remotely diagnose the problem, if we can solve it remotely, it's a big savings to have that management. Connectivity. You know, the broom closet may not have been pre-wired with Cat6 cable, and it may not have, Cat6 cable run to all the sensors and all the cameras throughout the gas station. So having Wi-Fi might save a whole lot of deployment cost for this type machine. But I guess maybe fundamentally, what's an edge server? And why would we build something called a server versus a gateway? So the way I see this, and maybe this sounds strange, but there's a lot of mission critical work that happens in the gas station. it may not seem mission critical, but it runs cash registers, runs credit card transactions, runs video surveillance. If any of those don't work, you, as the gas station owner, you'd be very disappointed with the results. If you can't sell gas and you can't sell alcohol, you would be very disappointed. So those are fairly mission critical functions. And so you're going to want IT on premises at the edge that's robust, that's clustered. I believe IoT will also become a mission critical app. Maybe the perception right now is that IoT is not mission critical, because a lot of what we're doing right now with IoT is telemetry, right? Monitoring and collecting. And if I lose my monitoring, that's disappointing, but it's probably not mission critical. But like Saurabh talked about, if it's actually doing control, if it's actually doing activation, which is where we're going with IoT, if it's actually controlling and taking actions, it's probably mission critical. You'd be very disappointed if it didn't shut off the gas valve like Saurabh talked about, right? That's really a mission critical. So that really drives server class equipment. I mean, larger, more than just ECC memory, but it needs clustering, it needs 10 gig Ethernet, and I assert it needs to run virtualization and consolidate multiple of these features. So you need large memory footprint. Maybe not just for SQL Database Edge, but because you're consolidating multiple functions that are all using the SQL Database Edge. So that's sort of this new class of device that we call an edge server. Just to see kind of, this is what I was holding up, but you can see some of the mounting options. You can mount it on a wall on the right-hand side. That's a DIN rail, so you can mount it either vertically or horizontally. We've got customers that want to hang it in the ceiling because there's no wall space even to put these devices. You can stack them on a shelf, and the lightweight is very helpful in terms of their flexibility. So we intend to test and make available SQL Database Edge on this device, as well as a number of other Microsoft products like Azure Stack HCI with that full S2D functionality. So this is one of our Edge offerings. We also plan to make SQL Database Edge available on other devices, right? Imagine it on an Android smartphone, right? On our Moto Z devices, for example. So I think a lot of use cases that you can imagine as you start to marry the devices together with the application capabilities. Jane?
Thank you so much, Greg and Saurabh. So we hope that with our presentation today, you get to know a little bit of how we are designing this product and what are the key capabilities that we're introducing into the core engine. This has been an extremely humbling process for us, because for every customer and partner conversation, there's always something new, some new insight that we learned from that conversation. So with that, we want to announce our early adopter program for all the people that wanting to get the access, get to play with the bits together with us. Essentially, we are not the expert to manage a connected factory. We're not the expert to run a transportation company. We are trying to really enable our developers to build more applications and telling us what is the most important things for you. So we call it early adopter, but essentially this is really the early trial process for both of us to learn together and really getting onto the journey of unlocking more intelligence right on the edge. So remember, aka.ms/SQLDBEdge-EAP. We hope to see you there. Thank you so much.
Thank you.
We still have a few minutes, and if you have any questions, please come to the microphone, and we're happy to address.
Hello, it's a good talk. Thank you. In fact, I'm a true believer of edge computing. I think definitely is the way to go. It's not 10 years ago as the cloud computing. Now it's the age of edge computing. I'm so glad Microsoft is providing an important component here, the database. My question is really about, in fact, I already found that there's a missing edge framework there. So for this new component, the database at edge, how could the developers to develop something on this, like the development process, testing process, and even the deployment of this database on edge?
So the question is, and please correct me if I'm wrong, what is the development process or what is the deployment process for Azure SQL Database Edge? Right? So from a deployment perspective, let's talk about that first. What we would make available is a container image which has the bits and pieces necessary for Azure SQL Database Edge to run, right? Now that container image could be deployed as part of your Azure IoT Edge solution, or could be deployed as an embedded container on your OEM devices. Right? So that's the deployment part of the story. The development part of the story is we would enable Visual Studio Code-based projects and Visual Studio-based projects for users to connect against Azure SQL Database Edge instance and create their schemas for the database, and also to create their streaming pipelines. So how to ingest data, what are the sources for the ingestions, and things like that. So some of those things we are trying to land over the next couple of months, and we will make those available as and when we land those. But if you enroll into the private preview, we will send you a quick set of instructions which you can use with Visual Studio or Visual Studio Code to code against this. Okay. Yes, sir, please.
Jeff Clark, my understanding was you're using CDC for managing the changes in.
I could use CDC, I could use change tracking,
Yep.
and or I could use temporal tables within SQL.
So if you're using CDC, do you manage the version changing if there's a schema change? Or is that something that the...
CDC does not address schema changes. CDC changes tracks the data changes. But for schema changes, what we are enabling is, so in SQL we have something called DACPack packages.
Yep.
With SQL package.exe, which if you deploy, it allows, or it tracks the diff between the source and the target schema and only applies the diff. So we will enable SQL package.exe for Azure SQL Database Edge.
SQL CDC allows 2 versions to run, so if you change, you can run and keep it going and cope with the change, and just need to check it's not it's backwardly compatible. You can you're talking about CDC or? All CDC, yeah.
This change data capture in SQL is only for data changes. So actual DML which makes changes to data. I know that because
beg to differ. Okay.
I used to own CDC as a product, as a feature in SQL. But
I've implemented in other situations, so we're obviously just misunderstanding each other. Don't worry.
So let's talk about that in a bit. Any other questions? How many of you are excited to join the EAP? Okay, nice. Thank you. Cool. So thanks, guys. I'll see you on the EAP, and we'll talk further. So when you sign up for the EAP, you get to work directly with the product engineering team, building the product. And we would want to hear your feedback and scenarios which you are implementing so that we can make this a world-class product. Thank you.
And if anyone wants to come up and check out the server, feel free to come to the front.
Thank you so much.
Thanks, guys.